Okay, so we had the homework worksheet from a couple days ago that we finished up yesterday. Did you get the assignment from yesterday, Eugene?
No, I didn't.
It was a quiz to find the area of this first problem. Now, I should probably draw this correctly. So circles overlap. Close enough to correctly, at least. Okay, so that's what we have. I connected the centers, and we were given that center-to-center distance of 0.85 inches. Diameters of 0.8 and 1.2 inches. So we've got 0.6 and 0.4. If we cut this off here, this is 0.2. Which makes this distance a squared plus b squared equals c squared. Well, this is one of the legs, right? Where?
Oh, that's right.
Yeah, that's the bracket thing. Yep. Oh, sure, it does kind of. So that length is 0.85 squared minus 0.2 squared because we have the hypotenuse in one of the legs. So second square root, 0.85 squared minus 0.2 squared. 0.8261. So that distance is one of the things we were meant to find, 0.8261. So now to find the whole perimeter of this, we got to find an angle. So let's find this angle right here. That angle is going to be the inverse sine of 0.2 over 0.85. $13.609. 0.61, but the only reason I'm putting it as 0.609 is because I have to multiply it by 2.
I have 13.240.
So I'm getting, nope, it should be 6. You use the 8261 instead of the 85. It should be 0.85. Did you do an inverse tangent or an inverse sine?
Inverse sine, I think.
Okay, did you use 0.2 and 0.85?
I must not have.
Okay. Because that would change it a little bit if you did use the 0.8. If you use this one instead of the 0.85. So we get, what we're getting here is the whole angle is 27.22. What I mean by the whole angle is, if I cut this like this, I'm talking about this whole angle here is 27.22. Which means this angle is 180 minus 27.22 degrees, otherwise known as 152.78 degrees. And this angle is 180 plus 27.22. Come on. There. Otherwise known as 207.22 degrees. The reason that's important is I need to find these arc lengths to find my perimeter. So that arc length there, I'm going to take my diameter of 1.2 times pi times 207.22 over 360. .17 inches is that arc length. Over here, I'm going to take the diameter of 0.8 times pi times 152.78 over 360. Giving us 1.102. Oops, this 152, not 157, that's why. .067 inches. And to that, I'm going to add the 0.826 and another 0.826, which will give us 4.889 inches is my perimeter. How many of you got that, or something really close to it? Nobody?
4.9805.
That's a little far off. You're off by a full tenth.
I think you miscalculated your triangle.
Which one? The point. This. Or the angle.
The hypotenuse. And
well, the 0.85 is the hypotenuse. The triangle looks like this.
Right, well,
this is 0.2 and this is 0.85.
Alright, well, even if you don't use the hypotenuse, okay, if you take and you want to find the angle that you found, you can do second tangent and then do 0.2 divided by 0.85.
No, you can't. That would not be a tangent. That would be a sine. 8261 is this side, right? Is that what you came up with for that length?
No, I got 0.87. Oh,
you added them instead of subtracting them. You treated this as the hypotenuse instead of a leg. It's one of the legs.
0.85 is a leg.
Nope. This is the right angle here. 0.85 is across from the right angle. It's the hypotenuse.
Seriously?
Yep.
Okay.
So that's what had you wrong, is you had your... That's why your angle was off too, slightly.
That angle over there, is that considered a half angle?
That's a half angle of the whole angle, yep, and that's where they get the 13.609. So that's why we doubled it to 27.22.
Well, Dustin did the same thing with me then.
Okay. So that might throw off your areas. So if you need to go back and recalculate that area on those, keep her for another day and do it.
I'm gonna need a new sheet that ran out of space for scribbling.
Just do it on a tablet page and staple it to it or something. Problem number 2. Now, problem number 2, I told you this had to be a tangent up here, right?
Yes, you did.
And this is a 1 4 slope. This is 8 inches, and I'm going to draw my radius in right here is 24 inches. There's a reason why I drew it in there, because I need it there. Well, because when it hits the tangent, it's going to make a right angle, right? So now the next thing I'm going to do is I'm going to do this. I'm going to drop this down here. I'm going to cut this across here. This angle right here is going to be the same as the angle formed by this aspect ratio, a 1 in 4. So this angle here is the inverse tangent of 1 over 4. (14.04 degrees). This is a right angle here. Like, since it didn't get drawn in to look tangent.
That looks right.
Yeah.
It's very confusing when you're looking at the sheet.
Yeah, because the sheet is a little off. I understand that. So then here, this angle here is 104.04 degrees. Now, of course, this has to be 90 down here. This is 90 degrees here. We just found this angle. How did we find that angle? Well, we know that these four angles in a quadrilateral have to add up to 360, right? So we take 360 and subtract all of those. This is going to be 75.96 degrees. Ever see how we got that?
That top corner there is bisected.
Nope, nothing's bisected yet. We just know that this whole angle is 90. We know this whole angle is 90, and this whole angle has to be 90 plus the 14.04, so 104.04. So right now we're not looking at any of the purple lines, we're just looking at the whole quadrilateral.
Okay. Carry on.
Next. He's just confused, that's fine.
Don't mind him.
We want to find this dimension here, I'll call A. And this dimension here, I'll call B. We have the 75 degrees and the 24 inches. Oops, 75.96 goes here. This is a right angle here, and this is 24 inches. So this side down here would be off of a cosine of 75.96 degrees equals A over the 24. So I put this over 1, we're going to cross multiply and divide. So cosine 75.96 times 24. A must be 5.88 or 822. This one up here then is going to be off the sine. Sine of 75.96 degrees is going to equal B over 24. Again, put it over 1, cross multiply and divide. So sine of 75.96 times 24. 23.283 inches. What does that give us? Gives us that's 5.822. If this is still 8 inches, right? Because this is 8 inches. This then must be 15.283 inches. You guys see how that works? See where the 15.283 comes from? I had the 23.283. I subtracted the 8 inches for here. This whole thing's 23. Subtract 8 leaves us with 15. So now then I have this triangle up here that we know has an angle of 14.04 degrees. And we know has this side over here of 15.283 inches. So I'm going to find the missing sides here. This side, I'll call that D and this E, is going to be found off of a sine. Sine of 14.04 degrees is going to equal 15.283 over D. So I put this over 1 times 15 divided by the sine of 1404. So 15.283 divided by sine of 14.04 gives us 6.997 or 62.997 inches. Down here, this is going to go off a tangent of 14.04 equals 15.283 is the opposite over E is the adjacent. So 1 times 15.283 is 15.283 divided by the tangent of 14.04. 61.115 inches. So now we have all the distances. is 61.115 inches. This up here is 62.997 inches. That's 8 inches. We know this angle here is 104.04 degrees. So we can find the arc length. We know this piece is 24 inches. That's the radius of our circle. Make sense? So you should be able to find the perimeter pretty easy. Is that what you needed? Because most of you said you didn't get that one finished. Is that what you needed to finish it up from there?
Yeah.
Most likely. Area is going to be pretty simple. You've got to find the area of the sector, which is, again, the area of the circle times 104.04 over 360. This, you've got a right triangle. This, you got a right triangle. And this, you got a rectangle. So area is pretty simple there. You got all you need up there? You need me to scroll down? Good.
I really just need the picture with the lines drawn in.
Okay. That is the tough part of seeing those triangles. And, of course, getting this angle right here. The real trick in this problem is this corner up here. Using the 1 in 4 slope to get this angle and adding it to 90 to get that whole angle. Because once you have that whole angle, the rest of it kind of falls into place. You have to divide the triangles. But that's the two things, is dividing into the triangles and finding that angle so that you can get this angle down here. Because with that angle, without this angle down here, you can't do anything.
How did you find that angle again?
This one?
Yeah.
Inverse tangent to the 1/4 slope gave me the 1404. Then since this was defined to be horizontal, that makes it a right angle to a vertical piece. So that's 90 degrees there, so 1404 plus 90 gives me the 104.04.
So there's inverse tangent of 0.25.
Yeah, of the 1/4, the 1 to 4 slope. Yeah. Okay, well, today we're going to look what are we going to look at here? So today I'm going to give you a problem. I'm going to have you work on it. Then we'll go over it tomorrow morning if we need to. I'm writing it down. So you're going to have to copy it down here. These lines are both tangents here and here. This is 72 millimeters across here. This is a 1 in 4 aspect ratio. Diameter of this big thing is 140 millimeters. I want you to find two things for me. Find that height. I'll put them in brown to clarify. Find that total height from bottom up to top. And find the width here between the 2 points of tangency. It's less than the diameter of the circle, obviously. Richard, you'll be in charge of sending that to Dustin, and
Yeah, somebody remind me, okay?
since you got a picture of it. That really is kind of neat compared to 10 years ago when you didn't really have that technology.
I was kind of wondering why you used the picture instead of just going back and looking at his video.
Because I don't have time to go back and look at the videos most